All right. Hello, everybody, and welcome to the stream. I hope you all are having a decent day. Just give it a couple minutes here for folks to file in. And while we're doing that, I'll go ahead and take a quick second to thank the supporters of the stream and project, for that matter. And they are, starting with the partners, Arslia, Gorboles Inc., Patrick Coolman. The partners are the highest tier of support over on Patreon and YouTube memberships. I'd also like to thank everybody else here on the screen. The other supporters listed here are the other tiers of support over on Patreon, on YouTube, and of course on Twitch. So thank you very much to everybody listed here. Your support is greatly appreciated. I'd also like to take a quick second and just thank all of you who follow along with the stream. Those of you who follow along on YouTube, where the archives of this are uploaded. And anybody who is interacting with this and following along. I really appreciate you guys being here. And yeah, without you guys, this wouldn't exist. So thank you very much for being here. All right. So tonight on the roster, we actually have some stuff to do for our Rendergraph in terms of gathering the data needed for our individual render passes. So what we're going to do tonight is basically replace the sort of packet system that we had in place before. And that is basically going to be replaced with filling out the pass data within the render view passes. Okay, so that is what is on the roster for tonight, and what we're going to be primarily focusing on. I did have a bug that sort of came up as well that I wanted to discuss, but I don't think we're going to get to that tonight. We might wind up having to get to that tomorrow night, only because I need somebody to test it on some specific hardware for me, and so until that's done, I can't actually release it, but if you guys are interested, there is a branch out there with it. And so we'll probably touch on that tomorrow night. But it's a very interesting thing, nonetheless. All right. So, with all that said, what we're basically going to do is we have this application prepare render packet. And within this prepare render packet is where we're kind of gathering all the data that we need now. So we're kind of filling out these render packets and then firing them off or returning them really to the engine, and then the engine then passes them to the next function, which is the application render. So we're going to be changing this up a bit, and we're going to actually have to change the interface here a little bit, because we're basically going to do away with these render packets, because I've decided that system is probably not going to be the best way to go. So we're replacing that with our configurable render pass, and then the application kind of knows what to do with this anyway, so we don't really need that generic structure anymore. Wajiller, hello. I hope I pronounced that correctly. If I didn't, let me know. But welcome to the stream. How are you doing today? And I know that chat says 133. This is episode 134, actually. And that's because I forgot to change the title before I went live. But yeah, this actually is episode 134. Doing good. Added functions to my programming language. Nice. What programming language are you working on? All right. So I think probably the best way to handle this is if we take a look at the engine, we can go ahead and application. Actually, I think this is going to be prepare. It's probably going to be the better thing to search for. Prepare render packet, right? So this is basically what we're going to be replacing. We have this interface point of the game instance, prepare render packet. And then we have this render down here as well. So we're going to be replacing both of those things. So right now, prepare render packet takes the game instance, which we want to keep, the packet, that's what we want to get rid of, and the frame data. So all we really need is the game instance and the frame data, and the application should be aware of everything else it needs. So let's go to definition here, and we'll remove the render packet. You're making a compiler. Nice. You got into the Jai beta, so that's pretty sweet. I wish I had the time to play around with Jai. That would be a really interesting thing to play around with. I don't have the time to do it. Coffee. Yeah, you're talking about VS Code. How are you doing tonight? We can't say that here on the stream, but, you know, I can bleep it. I can say VS Code. We can bleep it. But, yeah, didn't see you there. All right. So we've removed the packet here. I'm going to remove it from the comment there. And then we're also going to remove it from the render as well. And remove that from there. So we don't have all this passing around of data between the engine and the application anymore. The application is just going to hold on to all that stuff itself. Since it's fully aware of what it needs to do, the engine doesn't really need to know about it. Okay, so we'll save that. And, oh, you know what? We probably ought to rename that too, because we called it prepare render packet, which is actually kind of wrong. Let's see. Maybe we should do prepare frame, and then maybe we should rename this to render frame. I think that's how we're going to do it. So let's just call this prepare frame, and then render frame, right? And then we'll say function pointer to applications prepare frame function, and then we'll just change this here as well, right? Could only get Jai working on Windows because you're a NixOS user, so you just have to use VS Code. Yeah, I gotcha. That's unfortunate. So it only runs on Windows though? Or is it just because you're on NixOS? So that'd be kind of disappointing. I would definitely want to run it on... I'm an Arch, by the way. I would want to be able to run it here. Oh, it's a Nix issue. Okay. I wasn't sure if he had gotten around to cross-platform yet. Okay, that's pretty cool. All right, so we have prepare frame, render frame, so that should be good there. So all we need to do here is remove the packet, and then here we'll remove the packet. And then we have this cleanup packet, which we're no longer going to need. And I guess we actually don't need this anymore. I think, I don't think anything down here actually uses that packet or references it. No. Okay. So that's good. That's updated from the engine's perspective. Now we need to go to testbed main and update this here. So we'll say application prepare frame. We'll get rid of the render packet. We'll also get rid of the render packet here. And we will rename this to application render frame, which I'm pretty sure that's not going to carry over to the C file anyway. So we'll probably have to do it there too. And those, we're just using render packet. We can get rid of the render packet from there. And then testbed main, let's do prepare render packet. So this just needs to be prepare frame. Remove the packet. And then Oh, interesting. It did carry over this time. Sometimes it doesn't. Sometimes the refactor is a little bit weird. The builds for Linux are on Ubuntu. Yeah, I didn't think it was going to be quite as simple as, like, just downloading a package from the Arch user repository or anything like that. I figured it was going to be somewhat of a manual process, but... Is it only... Well, even if it's binaries, you should be able to, like, extract those unless he's, like, providing it as a package, like a prepackaged thing. All right. So, let me think. Is there anything else I need to do before I start this? I don't think there is. So, all of the packet view stuff is going to wind up getting wiped out, right? But, or I should say replaced. So it's not going to quite be just like deleting this whole thing. But there are steps of it that we're going to have to extract to do here instead. So we don't need that stuff. We don't need any of this stuff. We do need this. So let's see. So our simple scene is also going to have to change because it is dealing with a populate render packet. What is this actually? Populate render packet. So I think this is just setting up. Okay, we're creating a frustum here, so that's what we're using the viewport for in the camera. So we can do that all in the application. This is just grabbing the scene, world data, skybox data, skybox. So we're just grabbing a pointer there. We're clearing some arrays, which we can also do elsewhere. We might be able to get rid of this world data object as well, I'm thinking. And then we start looping through meshes and doing all of that. So I think actually all of this can be moved out of simple scene, right? So this is another one of those places where the simple scene is kind of handling rendering based stuff that it really shouldn't be. It really should just be worrying about, like, this is the scene, this is the objects I have within the scene, and then that's it, right? So we're actually going to remove this function out of here too to decouple this stuff a little bit more, which is going to make our whole system a heck of a lot more flexible because we're just going to offload that onto the application itself. Is there anything in C that I would like to get changed? There is one thing. Constant expressions would be nice. I would use those if they were in C. And part of the reason I would use those is because I could have compiled time string hashing, which would be super useful. I still don't know how I'm going to accomplish that, actually. Because that is something I want to set up for this, and I haven't completely wrapped my head around how I want to do that. But eventually, yeah, I want to kind of figure that out. And I really would like to avoid some sort of preprocessor hacking if I can avoid it. But yeah, that would be one thing. That would be nice. Let me think. Is there anything else that I would actually use? Maybe, and I say maybe, operator overloads would be nice to have. I think that's about it, though. C is a pretty great language on its own. I like the fact that it's simple. What about pointer syntax? Oh, you mean like the arrow versus the dot? I guess, yeah, the arrow versus the dot is kind of annoying, I guess. Yeah, I'll give you that one. Wade Watts, thank you so much for the follow. Appreciate that. Yeah, I mean, that does trip me up sometimes, especially if I change something from, just a regular vector 3 like this and make it a pointer. Then I've got to go through and change all that, which is, yeah, I guess that is kind of annoying. I guess having a dot for everything, like a lot of other languages like C# does, would be nice. But I don't know. I kind of like the little arrow sometimes, though. I know it seems silly, but yeah. I kind of like the way it looks in code. I don't know why. But yeah, having to do both is kind of weird. Like, I wish it were one or the other, but yeah. Okay. So we don't need the frustum until we actually do meshes. So I'm just going to grab the... Actually, I don't even need to really grab this, right? I could just extract this straight out of the scene itself. So... I guess what we need to do here is say states skybox pass, and this is going to be in the past data, extended data. We're going to have to cold cast this guy to skybox pass extended. Why do we not have... Why did that not come up in my IntelliSense? I thought I included these. Views. Skybox pass. Skybox pass extended data. That is what I typed, I think. Yeah, okay. All right, so I guess I'll do, actually, this is C, so I can just do this. ext data equals that, right? You can't do that in C++, by the way. You'd have to actually explicitly cast it here. But in C, you can get away with that. So that's another advantage over C++, right? I guess unless you cast it to the wrong type or something, but why would you do that, right? All right. So here, so if the scene is loaded, then we can do this. We can say ext data skybox equals state what was that under? What was that under? World data. Render view world data. Oh, it's just scene skybox is all it is. Okay. So it should be state scene main scene. I should probably rename that skybox. Okay. And then actually we can get rid of... I'm going to comment that out for now. All right, so for this particular pass, all we have to do is actually set that up. So that's nice and easy. I'm going to actually scope this because I want to reuse the name ext data for multiple scopes. So the next one is going to be scene pass extended data ext data equals state scene pass data ext data. Hey, Weird Trash Can, how's it going? Welcome. Welcome. We are in the process of gathering our data for our render views now. Okay, so the part that we have to extract out of here, and this being the populate render packet from the simple scene, is pretty much all of this stuff. So I think probably what I'm going to do, let me see. So we're pushing all this stuff to the packet and then doing render view system packet build, which is probably doing something else entirely. I think that's what's handling all the sorting. So this is actually going to be a two-step process, I think. Okay, so we don't need the view packet stuff. We don't need to do this, any of that. So we can start grabbing it from here. And take it all the way up to... Let's take it up to there for now. Because after that, we actually have to see what this is doing, and we're probably going to have to do that logic next. So I'm going to call this, let's say, Grand Poilu, thank you so much for the follow. I appreciate that. Thank you. And welcome. Populates scene pass data, I guess, for now. And then I'll just put a note here. Was packet build, just so I know what is supposed to go there. And current camera. Let's see. Current camera was state world camera. And then we were also using world viewport. Okay. So that makes sense. So I think what I'm going to do to make this fit in nicely is I'll just say camera, current camera equals state world camera. Is that a, might need the address of that, or no, that's already a pointer. Okay. And then we have viewports v equals state world viewport. That does need the address of. And then we have just a scene variable here, which instead of typing state main scene, I'm also going to create a convenience pointer for that. So I'll say scene, simple scene rather. Simple, oops, scene equals world, whoops, state main scene. And we need the address of that. Okay. So that is all of that. That's probably going to get us about 90% of the way there. Okay. So, this is mostly going to remain the same as what we had before. So we loop through each mesh, grab its model matrix, check its winding, loop through each geometry in each mesh. This is view frustum to see if it actually is within the view frustum, and then it gets added to, let's see, scene, world data, world geometries. This I want to change. We have a D-array push here. I want to do away with that, I think. Because we're pushing this into an array, which is going to cause a whole lot of reallocations. I would rather just create a flat array up front. Because we already have a We already have a mesh count here. Well, wait a minute, though. We're pushing the individual geometries, aren't we? So I suppose we could loop through everything and get a count on that first, I suppose. Or it could just reserve like a large number. Let's use our frame allocator for this. We'll do D-Ray create with allocator. And we're going to say, oh, you know what? Do I have, actually, instead of create with allocator, can I do D-Ray reserve with allocator? Right, because let's make a larger one so we can avoid some of those reallocations up front by adding a lot of stuff. So the type of this will be geometry render data. The capacity, I'll start it off at like 512 for now. That should be sufficient. And then the allocator is going to be p-frame data allocator, right? And then we have geometry render data, and we'll call this world, geometries. And that's what we'll funnel everything into for now. I'm doing good. Trash can, I'm doing pretty good. Figured out what I was maybe going to a little fast. Figured out I was maybe going a little too fast to use Vulkan and got back to OpenGL. I mean, that's fair enough. If you're still trying to understand high level concepts, there's nothing wrong with that. But at some point, you'll probably want to, expand your horizons beyond OpenGL, just because it's deprecated. But there's nothing wrong with writing stuff in that now. La Pizza Cabra. Not sure if I pronounced that right. Just wanted to thank you for everything you're doing. After the Unity fiasco, learning to make our own engines has become really important. First of all, thank you for the feedback and first-time chat. I appreciate that. Thank you for being here. But yeah, I couldn't agree more. I think learning to roll your own tech is invaluable. If you're capable of doing it and you have the time and resources to do it, it's definitely, I think, a much better way to go, because you're then not beholden to somebody else's way of doing things. You're not beholden to having to deal with licensing changes and exactly the same type of situation that's going on with that, right? You feel you're a little behind in the math. Yeah, I mean, that's fair enough. I'm no math expert myself. There's a lot of that stuff, like every time I go to implement it, I have to look it up because I can't remember it, right? Grand Poilu, still learning the basic of C#, and I'm finding your stream is incredible. Keep up, man. Thank you. I appreciate that. And first time chat. Thank you for joining and welcome. Welcome to the stream. I hope you are able to gain some stuff for it. We're pretty far into the engine development at this point, but ad break. Grand Poilu, thank you so much for the Prime subscription there. I really appreciate that. And since you're subbed, I know that you can hear me now. You shouldn't be getting any ads, so thank you very much for that. I really appreciate the support. Got about another 35 seconds or so on ads. All right, and we're back. So just in case you didn't hear me, Grand Porlo, thank you so much for the Prime. I really appreciate that. And welcome. Weird Trash Can. I'm trying to get a better grasp in C# for backend, but still trying to decide if I should go the C# route or Java. So it really depends on what kind of backend you're targeting, right? Because there's different tech stacks for different uses. I tend to not recommend Java for anything. I'm not really a fan of Java. I think C# is a far superior language, but that's just my opinion, right? So take that with a grain of salt. But all the back end work that I've done over the years has all been C# based for anything web based. So take that how you will. Tammin, hello. Good evening. How are you? You finally got back into engine programming. Awesome. Welcome. Welcome back. After almost 2 months break. Hey, I mean, sometimes you got to take a break, right? I've certainly done it. Personally, I'm doing C# because my class needs it, and I look up a bit fast Java, and damn, I find C# is way easier. Yeah, I tend to agree. I like the way that C# kind of fits together just better overall. Oh, Tammin, you're Portuguese. I didn't realize that. Are you in Brazil as well? I feel like C# is better because it feels so much more modern. Yeah, it definitely is. Woe based God take. What do you mean, coffee? Let's see. I came across your YouTube channel a week ago. I've been itching to dive into the engine playlist. It's definitely time to start now. Awesome. Yeah, it's never too late to start, for sure. This is episode 134, so you've got some catching up to do, but the videos aren't going anywhere. There's no rush, right? So it did kind of start as a tutorial series, and then eventually, I changed the format a few times trying to figure out what works, what doesn't, and we eventually just kind of moved over to this live stream format. And that's what's being archived now on the YouTube channel. But yeah, for those of you that don't have it, I'll just drop my socials here real quick in chat, just so that you guys have all that. Tammin, you are Brazilian. Okay. Yeah, I was wondering. Yeah, I mean, the command prompts are really intuitive. Like, you write like what you think. You know what I mean? Yeah, I do know what you mean. Yeah, command prompt is and if you like command prompt, you'll like the Linux terminal even better, or even on Mac OS, right? If you like the command prompt on Windows, you'll like Linux a lot better, I think, once you get used to it. You mean .NET CLI, right? It's far better than Java's build systems. Yeah. But, I mean, it does have the advantage of being a far newer technology, right? Java has been around a lot longer. So there is that. But still, ew, Java. Okay. So, we were coming in here and doing world geometries. What is this bleating about? Oh, it probably needs the address of that instead. Yes. Okay. So instead of going into this, where was it? Instead of pushing the render data into this world geometries, we are going to push it into this world geometry's local array that we're sort of creating. In fact, actually, don't we have that? I think we actually have that on, let's see, that would be the ext data geometries, I think, right? Yeah, we do have that. So let's actually just push directly into that array, right? Let's not even mess around with this stuff. Let's just push it right into that. What I am going to do is go over here to scene, though, because we have this world data with these arrays in here, and I want to get rid of those so that we don't actually accidentally leave something there, because that's going to be a vector for bugs. So we have... That's all that's in here, actually. Skybox data. So this essentially is again, packet data, right? Yeah. I'm going to nuke this entire thing. Don't need it. Right? And I think the only thing that's actually using that in here is this populate render packet anyway. So once we actually get rid of that, it won't matter. All right, so instead of pushing to that, we push to ext data, what was it, world geometries? No, just geometries, okay? So La Pizza Cabra. I hope I'm pronouncing that correctly, but thank you so much for the follow. I appreciate it. So we'll say geometries, right? And now we're pushing into that. Let me just catch up on chat here. You hate Windows command, but I kind of like PowerShell. PowerShell's okay. It's better than command prompt, but it's still far inferior to a terminal, a bash terminal, right? There's no better option. I mean, you could use WSL, Windows Subsystem for Linux, right? Wait a minute, did I read Rendergraph? Yes, that's what we're working on. Yep. Let's see. Damn right, this stuff is way too advanced for me, but I really like watching. At some point I'll learn something. Yeah, so if you're starting with the series and you start in the very beginning, all this stuff will make sense, right? So one of the things that we're doing in this series is we're actually kind of experimenting and trying different stuff to see kind of what works and what doesn't. Because that's what happens in a live environment too. And, you know, sometimes you just get stuff that doesn't work. And so we have this render packet system here that didn't really work out the way that I hoped that it would, right? And it really just wound up being more complex than was worth. And so that's what we're factoring out now. Am I using VS? I am not. That's a cuss word around here. No, I only use it right now as a debugger, but I don't use it for writing any kind of code in. I use Vim. Let's see. Yeah, Tam, and it has been a minute since I've seen you in here. New scenario looks cool. Yeah, it's NeoVim. Yep. Yeah, so this is NeoVim, and I've got, you know, a whole setup here. My config file, I actually have. How long is my config file now? 778 lines. It's not too bad, right? But yeah, NeoVim is the best, I think. I've gotten really used to it. There's still some growing pains I've had with it. Still some stuff that occasionally trips me up, but I'm getting a lot better with it, and I've already figured out that I'm much faster with it than I was any other editor I've ever used. So, +1 for NeoVim. Yep, 100%. All right. You'll look it up? Yeah. NeoVim it's definitely, there's a little bit of a learning curve to it, and by a little bit I mean a lot. It's all keyboard driven. You almost never use the mouse. Sometimes I'll do it to sort of display things on here for you guys so that you can kind of see, but like I don't use the mouse very often at all. It's all keyboard driven and key chords and stuff like that. So it's a very different style of editor. It takes a lot of getting used to. Should I think VS Codium is also, I think that's also a cuss word technically. It's written in Electron, but why though? I mean, it's JavaScript. Why are you going to write an editor in JavaScript? I don't know. I mean, it's cool for what it is, I guess, but I just much prefer this. For those wanting to start with NeoVim, I recommend using, starting with lazy Vim setup 100%. Yeah, that's a good, and run Vim Tutor a lot. I hate that Electron is the thing. Yeah, I honestly feel like I should just be saying Electron. Like that should be bleeped as well. This is a family-friendly stream, right? So I should probably bleep that as well. So lazy Vim, then NeoVim. Well, lazy Vim is basically just a heavily customized version of it, right? So it's basically something that's like I've got this configuration, this super long configuration here, and lazy Vim just kind of gives you a lot of this stuff out of the box. So I haven't actually used lazy Vim. I started on like regular Vim and then I switched to NeoVim maybe 6 months ago or so, because it's every bit as fast, if not faster, than regular Vim now, but it's more modern. It supports things like Lua, which is pretty awesome. But yeah, I've not used lazy Vim, but I've heard a lot of people say good things about it, so. All right. So I think all of this can remain the same. None of that needs to change. We've already changed that to push into the correct array. Why is this still a to-do? That is definitely not a to-do. So we're going to go through the terrains. Check terrain generation, frustum calling. Frustum calling is something we need to do on terrains, but we have to chunk that. That is something we need to eventually add. Okay, so this is just going to be ext data, and then geometries. Right, so we're just going to push that into, that's going to be terrain geometries rather. We're just counting that as one mesh. We can leave this to do here. We're not really going to be messing with that just yet. Why is this bleating? Subscript pointer to incomplete type. Oh, we probably don't have terrain in here, do we? Let's see, we probably don't, I'm guessing. Yeah, so I guess I could put it here. Oh, that's resources rather. Terrain. All right, so that's that. Debug geometries. This is largely going to be the same thing, actually. So we can say ext data, debug geometries. And now we handle the directional lights, point lights, all that stuff. Now, I don't think... Let's see. Simple scene, debug data. Oh, wait a minute. We're going to have to extract this somehow. We're going to have some sort of getter for this, right? Because this debug data is internal to the simple scene. And that structure, in fact, is internal to the simple scene. right here. We don't really want to expose that, right? So we probably are going to have to... I'm thinking of the double call getter methodology here. Let's see, debug. So technically speaking, we should be doing all of this stuff like inside the simple scene. So what I'm thinking is we'll implement a function within simple scene that we call once to get a count of how many of these things there are, and then a second time passing an array of allocated memory to be filled out with all of these references. And I think that's probably going to be the way to go. And probably we'll just do geometry render data for that, I guess. Because the scene technically owns these things, but they're debug. Maybe I should just get all. Maybe I should get all debug data at once. Because at the end of the day, these things are all just going into the same array anyway. I think that's what I'm going to do. Instead of having separate arrays for each, it doesn't matter whether it's directional lights, point lights, mesh debug shapes, what have you. I think I should just make one that says get debug shape, geometry render data. It's going to be long. Let's go to... Let's see, we have... where do we want to put this? Unload. So we have the add, remove. Here's all of our getters here. So maybe I will group it with these guys. Terrain get, yeah, that's what we'll do. So what we'll do is we'll say, do we have this return in Boolean? Let's do that for now. So we'll say B8 simple scene debug render data get. Obviously, we'll need the simple scene. We'll need a U32 pointer to, let's call this data count. Let me move this up so you guys can see, because I'm programming behind my mug. And then we'll have geometry render data. And it's going to be a pointer to an array. And we'll call this debug geometries. All right, obviously we'll say if not seen or not data count, return false. And then otherwise we'll return true. And basically what we're going to do is we're going to retrieve the count and set that. And then if there is an array passed to our pointer to an array and over here, right, our debug geometries. If there's something passed here, then we'll fill it out. If there's not, then we will just return the count, right? And we'll do that to give the application a chance to allocate the memory for the count. GPU driven frustum culling, not yet. Eventually. But yeah, for now it's just CPU. It's a super basic check though. By the way, you found this system called Xmake, and I'm liking that so far. Have I heard of it? No, I have not. What's the difference between it and make? Getters, that's bannable. It's not really a getter, right? I mean, technically speaking, if you're saying getters are bannable, I mean, then you should ban Vulkan, right? Because Vulkan has getters. Which font am I using? It's, you know what? Let me look. Meslo LGS NF. So it's a nerd font. Yeah, no problem. The term is bannable. Could use another word. Yeah, I don't really like the word get either. What is there, like 30 some odd definitions for the word get? Yeah, I mean, just Google alone lists like 8, right? So I'm not a huge fan of that word either. We could say acquire, but it's not really acquisition of anything either, right? GUI font is used. I thought it's terminal, not GUI. Yeah, it is. It is terminal, but I have that in here in case like somebody uses it in I think what is it? GVim I think uses that. I want to say query. I guess I don't hate that actually. Yeah. Yeah. I don't hate that. Why have it be double called? So I'm kind of following a pattern that Vulkan uses a lot, which I don't follow a lot of patterns that they use, but this one I think makes sense. So I don't really want this to be responsible for allocating the memory that it fills out, right? I want whatever the caller of this to do that, right? But I don't want to have one method that says, okay, give me the count of these things so I can allocate it. And then another method that says, okay, now fill out this array that I've allocated. When realistically, I need the count either way, so I could just have it all be part of the same function. So I could call it once, passing 0 here, and that'll mean, okay, get the count and then just back out of the function. Or otherwise, get the count and actually do the thing, right? So that's kind of the thought process behind that. But too big, actually. No, Coffee, you're not wasting my time at all, honestly. Naming is one of those things that I struggle with a lot, actually. So I'm always open to input on that. No worries at all. All right. So I think basically what we're going to do is we're going to loop through each one of these types and then just kind of iterate that counter, right? And then within that same iteration, if we actually have something in this guy, then we'll go ahead and add it, right? So let's see. I guess we can kind of do it in the same order. Where is the, okay, so scene grid geometry. That's interesting. I could actually move that out of here. Yeah, I'm going to include it for now. Okay, so we'll say, first off, we'll say data count equals 0. And then I guess we'll start off with if scene grid, because I think, oh, I thought I made that optional. Can you not turn that off? We're always creating a grid. That seems kind of dumb. All right. I'm going to put a to-do in here. Check if grid exists. But for now, I'm just going to actually just do this. Right? So we'll have the, should probably scope this actually. And let's see. Data count plus plus. Probably ought to make sure that this happens. So we go ahead and do that. And then we'll actually say if debug geometries. Then we'll say debug geometries. Data count equals, oh, wait a minute. This needs to be dereferenced. I think that's right. So we dereference the array and then set the element. Only if we have a memory, right? So like if we don't have this, then we won't do that. We'll just increment the count. And that's basically the pattern we're going to follow, I think. Okay. So that's the grid data count -1. Well, it wouldn't be data count -1, right? Because we're using it here to index, and we've set it to 0 here. So we actually do this before incrementing that. So it should be the correct index at that point. Ramon CF and Tactile, thank you so much for the follows. I appreciate that. Looks like we have an ad break coming up here soon, so I'll kind of start this now. And we may have to break here in a second. So just so you guys are aware, I try to pause the stream whenever there's ads so that you guys don't actually miss what I'm talking about. So once that starts, I'll be pausing here in a second. All right, so if we have a directional light, and that directional light has debug data, then we go ahead and grab this. We're not going to do a D-ray push anymore. We are going to just simply actually do this. Okay, so that's the directional lights. Yep, that looks good. Okay. Point lights. This is going to be largely the same thing once again. Oh, we got ads. It's just 90 seconds of ads, so we'll be back here in just a minute. About 35 seconds left on ads. All right, almost there. All right, and we are back. So just as a reminder, I'd like to pause the stream for ads so that you guys don't actually miss anything. So we're just kind of continuing on here. So instead of just pushing to this array here, we just add to this guy here. So that should be good. We're kind of just getting our count and potentially our data at the same time so that we kind of kill two birds with one stone there. These are mesh debug shapes. So we'll go ahead and grab this. And copy pasta this. And we should be good with that. Once we've reached the bottom of this, we should have everything that we actually need. So I'll go ahead and take this and go to simple scene H, and I think I put that hit the wrong button in here somewhere. All right, get rid of that again, go back. This guy. I guess it is all the way at the bottom. All right, so we will expose that to the application. Geometry render data, I don't think we actually have. Geometry, nope, we don't. I'll just go here. Which means that needs to have the word struct in front of it. Okay. Am I following any resources for implementing the render graph itself? Not particularly. It's just kind of things that I've cobbled together over the years. And I've tried a couple of different render graph implementations over the years. And this is the one that I think will be most configurable in the end. So this is the one I'm going to go with. All right, so debug geometry, we're going to do double call in this. So we'll say simple scene debug render data query. We'll say scene, oops, wow, that was an awful letter there. Scene, data counts, let's say U32 debug geometry. Actually, I don't even need that. I could just pass in ext data debug geometry count, right? The address of that. And then for this guy, we're going to, the first call, pass 0. Right? I guess since we're returning a Boolean, we'll verify it, right? Oops. Failed to obtain count of debug render objects, I guess we could say. Return false. All right, and then we can grab this, paste it again, but this time we'll say pass, what is it? State scene pass. Oh, you know what? It's extended data. I won't, sorry. ext data. Debug geometries equals k allocates. And we want size of geometry render data. And then times ext data debug geometry count. And then this is going to be memory tag array. Oh, you know what? I don't want to use kallocate, do I? I want to use my... Calling this is a force of habit. I want to use my frame allocator, right? So I'm going to say p frame data allocator allocate. Does that not take the... Oh, it doesn't take the memory tag. Well, yeah, I guess it doesn't need to because it doesn't get tracked any longer than a frame. Okay. So let's get rid of this guy for a minute. So we have the debug geometries array created based off the size that we just got. Wow, what is this? Right. And then now that we've created that, we can call this again, passing the address of ext data debug geometries. And then we'll just say debug render objects, right? If you want, I could send you an article that I was reading. Has a nice approach to MT. I assume you mean multi-threading and automatically handling synchronization. Yeah, I mean, I'll take it. Can you toss it on the Discord server under, I guess under the Kohi channel works. I probably ought to like create a separate channel for that, like stream chat or something, but that way it doesn't get lost here in the stream. All right. So now that we have that, we should have that filled out. The next thing we need to extract is the packet build. So let's open, what did we call that? Render view world. And was it prepare packet? Populate. Build. Okay. All right. So this did kind of a lot of extra copying that I've been wanting to get rid of as well. So we're going to not reuse this directly because see, like all of this crap, it's bad, right? So we're going to get rid of all that. We don't need to fill all this stuff out. We've already got that. Now we do need to do this. We do need to handle this geometry distances thing, right? Where is that declared? It is private. Does that have in it? Geometry render data and distance. Oh, right, because we created an array of those things and then used that to sort. It's on Discord. Thank you so much. Appreciate that. Let me have a look at that real quick. Yeah, that should be an interesting read. I've got some ideas on how I want to do that using like fences. Cool. All right, so I will have a read later on that. So thank you for that. I appreciate that. And if it turns out to be a really good resource, then I'll probably also have you post it. And actually, you know what? Come to think of it, I wonder if there's a way I can move this. I don't know if I can move messages. Nope. We actually do have, I forgot, because we don't use it all that often, but there is a resources channel on there as well. So if you want, you can go ahead and post it in there as well. Sorry, I know I told you the Kohi channel, but the resources is probably a better place for it. All right, so these geometry distances basically have a geometry render data and a distance, and then we sort those based on the distance from the camera. I'm trying to think if I want to do it that way. So I'm thinking for a second. So this really only applies to meshes that have a transparent material, right? That's the only reason we need to sort some of these things. Because those have to be drawn in the correct order, right? And that's the whole reason we have that. So, how do I want to go about? Because I really don't want to use, like, I guess I could use a D-array for this with just the frame allocator. So let's say separate out. I'd really rather sort these in place if I can. I'm just trying to think about a little bit better of a way to handle this without so many copy operations. Basically what needs to happen is... Wait a minute. Well, that flag is called has transparency, but it's really not has transparency. That's named backwards. That's not confusing at all. So these are meshes with no transparency. These are meshes with transparency, and this variable is backwards. That's awesome. I'm going to rename this now because no. I don't like negative named variables like that, but it's confusing otherwise. Smudge, hey, welcome. How are you doing? All right. You know what? I'm just going to brute force this for now, and I'll clean it up later. Callous Fury, thank you so much for the follow. I appreciate that. Separate out the... We probably shouldn't... You know what? Let's actually do move transparent meshes to the end of the list, right? We'll keep a running count, and we'll just kind of keep moving things to the end of the list. Although that's gonna involve a lot of copy operations too if I do that. In fact, that actually might suck worse, come to think of it, than to just do it separately. All right, instead of doing this right here, just directly into this array, actually, I need that one, and I also need, let's do a, first of all, I need this structure. Right, I need this guy. So let's put him right here. Right. So I'm going to say geometry distance distances equals darray create with allocator. Geometry distance, and then the allocator is going to be p frame data allocator. Need the address of that. Right. And then we're also going to have like a temporary array. Oh wait, you know what? This is actually the wrong spot for this. It's been a long day, folks. I guess I'm a bit more tired than I thought I was. Okay. This is completely separate concern from this guy. What I really need is we have distances, and then we have geometry, or I guess I can say ext data geometries equals p frame data allocator allocate. We'll say size of geometry render data times. Do I have a count on those yet? Yes. Shoot. I think it's literally just going to be mesh count. Yeah, okay, mesh count. So, mesh count. Actually, wasn't I already pushing into this array? ext data geometries. Yeah. Oh, crap. Oh, I know how I can do this. I'm making this way more complicated than it needs to be. So geometries, we push into geometries if we're actually going to render it. But what we should probably also do up here, we'll say darray create with allocator geometry render data, and then p frame data allocator. And we'll say geometry render data transparent geometries. Or maybe... No, actually, instead of that, geometry distance. I swear this will make sense in a minute. I'm just trying to figure this out in my head before I try to explain it. So what we're going to do is in this pass, as we're iterating through all of our meshes, at this point, we'll go ahead and take a look at the material and say, hey, is this transparent or if it's not, or is it not? And then if it's not transparent, we'll push it to the geometries directly. If it is transparent, we'll push it to this geometry distances array. We'll then sort this array and then push all the entries in this array into this geometries array, and that will solve the problem for us. And we can all do that in line. So right here is where we would check that that flag. So where is that? We have that here. All right, so we'll just do this here. And GData is world geometries, right? So we don't actually, we actually just look at G here. Right, so G material type, we'll check if it's Fung. No transparency, we'll look at G material maps. 0, which is going to be the diffuse map. And I'm going to reverse this actually to a negative check to say if it's not equal to 0. In other words, the flag for transparency has been set. And then I'll say here has transparency. And then actually, I probably don't even need to do that, do I? Yeah, because we can account for different material types in here. So if we have transparency, we are not going to want to do this yet. That belongs in the else clause. Okay, so whoops. So if we have transparency, then we'll say darray push, and we'll say geometry distances. I guess that's what I called it. And we'll push I think it was distances, right? Transparent geometries. Right, and then we'll push data to that. And technically, either way, we're going to increase that counter, right? So check if transparent. If so, put into a separate temp array to be sorted by distance from the camera. Otherwise, put into the ext data geometries array directly. Right. Okay. That makes more sense. Work was busy today, so enjoying an evening chilling now. Yeah, same with me today. That's why I'm a little bit brain dead, I think. I was trying to debug something that was kind of annoying today. Any Emacs enjoyers? Silicon Milk, yes. First time chat. Welcome, by the way. You run through eShell and Emacs. You know, I tried Emacs a little bit, and I think I just got so used to working in Vim that it was kind of difficult for me to change to. One of these years, I'll give it a fair shot. I didn't hate it. It's just all the Vim keystrokes are kind of embedded in my brain. I suppose I could run Doom Emacs, right? That's the one that has all the Vim key bindings, if I recall correctly. All right. So we push those things into the appropriate array. And then before we move on to terrains, we can actually do the sorting. Oh, wait a minute. If this is... We actually need to do one more step here. So this guy over here... We need to do this for transparency. Right? And so this needs to be G center, G, oh, model. Don't we have, yeah, we could just use model for that. Oops. Right. C, this is going to be current camera position. Geometry distance. Get the distance here. This is the G here is going to wind up being, wait a minute. Is this? Yeah, that is just the geometry render data. So this is actually going to wind up being data. So what we really want to push here is gdist. Right. So now we have the distance from the camera and the data to actually be rendered. So we push that into the transparent geometries array. And now down here at the end of this loop, is where we actually do the thing. Wait a minute. Why did that kick me all the way down? Why did that kick me all the way down there? Am I missing I am missing a thing, aren't I? Yes, I am. Missing one of these guys. Wait a minute, I'm still missing something here. Somehow I wound up a brace, 2 braces short. Okay. Oh, ads. Got about 30 seconds left on ads. right, and we're back. Eva mode is your friend. I run Vim through eShell and Emacs. I still use the DI key combo from Vim a lot in Emacs. Yeah, it makes sense. I would probably wind up doing something similar to transition. But did you manage to debug it at work? No, that's the annoying part, is I didn't actually get to the bottom of the problem before the day ended. And I had to walk away from it, because sometimes what happens to me there is, like, I have to walk away from it, and then I'll come back, and then the solution just presents itself right there. Just sometimes my brain just needs to step away from it, you know? All right, so sort transparent geometries. Then add them to the ext data geometries array. Yeah, you dreamed about the solution of a code problem once, or the solution of a problem once? Yeah, I've done that. I've coded stuff in my sleep, and then, like, I've literally woken up, like, 2 or 3 o'clock in the morning and, like, ran to my computer because I thought of the issue in the middle of the night and coded it up right then and there. That's definitely a thing. All right. So, our sorting, we implemented a quick sort. We did it statically based on this geometry distance structure type. God, I hate to really copy this stuff. I really ought to make this more generic at some point, but I really don't want to do that right now. But unlike you, I'm too lazy to get up in the middle of the night to solve it. The problem is, if I don't do that, I won't sleep. So there's literally no point in me not doing it. All right, so this was... as much as I hate this, I'm going to put it right here. But... to make this more generic and move it the heck out of here. And I'm also, I guess I'm just going to call this, because I might need to do it somewhere else. So g distance. Actually, why am I doing it this way? Maybe the rename will work here. Let's see. G distance swap. Hey, it did work. Rename. G distance partition. And G distance quicksort. All right. So that's what I'm going to use. So that's going to wind up being here. So let's see, what did I do before? This is all the draw code. I don't need that. I think I literally just called that, right? Geometry distances. Okay, so I'm probably going to need both of these guys. So this is going to be, I think I called this transparent geometries. And then this was, what was it? G distance quicksort. Okay. That should be all we need to do as far as the sorting, right? We should just be able to drop that right in. And then we have, of course, this. Right, so we do I can get rid of that comment. So instead of out packet geometries, this is going to be ext data geometries. Geometry distances, this is going to be transparent geometries data. And then we already did the... Did we actually increment the packet with the geometry count? I don't think we did. I don't think we set that. Mesh counts, scene meshes. No, we haven't actually done that. So let's do here. Let's do ext data geometry count equals darray length ext data geometries. Now, you might be wondering why I'm storing off this count if we already have this as a darray. That's because this structure does not actually assume that that's a darray, right? That could just be a flat array. And I don't want to make the assumption at that level that that's the way that that works. So we do have to be using darrays here, but Hamster Dev, hey, how's it going? All right, so that is all the geometries, the terrains. This is pushing to terrain geometries, but have we allocated that yet? I don't think so. So we have this, but I don't think we've done that here. Right, so this is going to be... I'm still going to call reserve on this, but I'm going to reserve one space. You know what? I'm going to reserve 16 spaces because we are going to chunk this eventually, right? So, oops, what did I do? 16. Yeah, let's go ahead and do that, and then we'll say terrain geometries, right? And we'll go ahead and set the count here too. So ext data terrain geometries. Set that to 0, and then we'll actually increment it down here as well. So, well, I guess we could just get it from the darray length, right? So ext data terrain geometries equals darray length ext data terrain geometries. Oops, this should be terrain geometry count. Okay. We're still going to count this in the drawn meshes because we're counting that as like another drawn mesh, so that's fine. So that's terrains. Debug geometries, we are allocating this here. And we're already getting the count here, so that should be fine. And we don't need that. Okay. I think that is literally all that this is doing, right? Now, I know in here we had to clean up the geometry distances array that we had, because we were just using a regular D-array, but since I'm using the frame allocator in here, it just gets thrown away at the end of the frame. So I don't think I have to worry about that. Okay, so let's have a look here, because I feel like the structure of this is still off somehow. Right, because like this is... No, maybe not. Maybe it isn't. I think this is the check to see if the scene is loaded, right? Yeah, okay, so the scene is loaded. So this is just saying to make sure that we have a viewport. I don't think this actually applies anymore. I think we can get rid of that. Right? Okay. Inject debug geometries into world packet. But we don't have to do that because we already have that data being set here. Oh wait, I'm wrong. So these are the debug geometries in the scene. These are our raycast debug geometries. So those do have to actually be. Let's call this raycast debug geometries, just so it's clear. Into the scene pass data. So we'll do the lines first, I guess. And then we're going to push into... Ooh. We're going to have to re-get this extended data. Actually, we could just move this within the scope here, and that should be enough. Yeah, there's no reason these can't be in that same scope. They're being added to that same packet. Let's get those in here. I don't think I need this anymore either. I'm going to get rid of that. All right, so ext data, debug geometries, undeclared identifier. Did I not move that in? Oh, right. I need to move it one more block in. Right. Right, so that's where the scene is loaded, right? So we can do... So we push this into debug geometries. And then I guess we can just increment that, right? So we can just say ext data debug geometry count plus plus, right? So we can do that same thing there. Okay. I think that's fine. So that is that. And that is actually everything gathered for that pass that we actually need for that particular one. So the editor world is going to be, I think the gizmo is actually all we need for that. So actually, let me go back up here. And I'll grab this just as my example so I can remember what the heck I'm doing down here. Okay, so we'll paste this here. We don't need this. We don't need that. This is going to be editor pass. Editor pass extended data. And then I think all we have to do is say ext data. We have debug geometries here. So this just took the gizmo. So it looks like in our render view system packet build, it actually figured out what geometry you need to use. So we need to open that guy up. Build the world packet. All right. Yeah. See, here's where we actually build out the render data for the appropriate geometry. So it should just be this section that we basically need. So just put this there. All right. And this is going to be if where do we get that? So this is literally just state gizmo. Okay, so actually, I think this literally is just a flat object, so that's always going to exist. Right? So this is going to be state gizmo model data, state gizmo mode geometry. So we get the geometry from that. State gizmo xform. State gizmo scale. I need to figure that out actually at some point. This is all the same. We create a geometry render data, and then this just goes into the packet or for the extended data, right? So in this case, I say ext data dot debug geometries equals p frame data allocator allocate size of, and this is going to be geometry render data. Whoops, geometry render data. And I'm just going to hard code a 1 here because we only have just the one thing. ext data debug geometry count is 1. In fact, to make this a little bit better, let's actually do ext data debug geometry count, right? That way it's only hard coded in one spot. Okay, and then we just push the render data onto that. Oh, you know what? Because there's a potential here for us to have 2. Oh, and this is a D-array anyway, so we actually don't want to do it this way. We want a D-array here. So D-array create with allocator. And we'll just use this type instead. And then we'll use p frame data allocator. Need the address of that. How are nanites coming along? Yeah, I'm not quite to that point in this engine yet. I think it'd be really cool to develop something like Nanite, but yeah, that's quite a ways off. Definitely not something that I would implement in like version 1. Okay, so we create our debug geometries. I'm going to move this down here and change this to darray length xt data debug geometries. We'll just get it straight from that. State gizmo plain normal state okay, and ext data debug job. God, I keep hitting that key combo to bring up that help menu. It's annoying. I'm gonna have to disable that. I understand I initially thought maybe there is groundwork for it needed that could be considered in low level state we're in. Not really. Like we're trying to make things so that we can call the renderer in such a way where we can do any of that kind of stuff that we want to. So that when we go to add that feature later on, we don't have to like overhaul the entire renderer, right? Obviously, there will be some work needed to support something like that, but it really should be a system kind of outside the renderer on its own. And then it should just feed the renderer that geometry data, ultimately, right? So I don't think there's really too much groundwork other than what we've already done for that, other than just developing that system itself. Okay. So we have the debug geometries, the debug geometry counts. We don't need any of this stuff anymore. And that is it for the editor world. We're just going to call this the editor pass. All right. So that's that. And the last one. Well, okay. So we have wireframe in here. We're turning that off right now. We'll implement that pass as something different in a bit. UI. UI is going to be a little bit more work. So let's go ahead and grab this. So this is going to be UI pass extended data. UI pass. Okay. We don't need this. Don't need this. We should probably also pull up the UI view UI and just see what all we might actually need out of here. Build. I don't think it's going to be too much. I think it's just literally adding the meshes. Set extended data to the test text objects for now. UI packet data. Okay, we may have to revisit that a little bit. We'll see. Okay, it looks like we fill out the packet here. So we actually add the texts to the packet. What do we do to render those guys? So we do geometries first, as we normally might expect. Then we have the bitmap text. What does this... Did we do the same thing in here? I think we actually did. Okay, so this might actually drop in for now. We really need to like refactor this as well to not like use these things directly. But I think for now I'm okay with that. We don't need this. I don't know why this highlighting is so weird, but I'm just going to kind of space that out a line. So I'm thinking we have UI meshes, but doesn't. Let me just try and understand why we were allocating this. So we have UI meshes. And we're saying state UI meshes. So it's like we're taking a copy of, we're taking a pointer to this. Mesh data meshes, UI meshes. We don't need to do any of that. Because we have all the data, we can extract all the data we need from that right here. We actually don't have to do that step at all. Okay, so let's figure out, let's do the UI meshes first, and then we'll do the texts next. Which technically we shouldn't be ordering them this way. We should probably have some sort of definitive order as provided by like UI system, so that we can draw the correct things on top of one another, but we're not there yet, so. So I guess what I'll say is, we have 10 here. How do I want to do this? Okay, so we'll say ext data geometries equals darray reserve with allocator. And then we'll do the type of thing that's going to be is going to be geometry render data. The capacity we're going to start off with is 10 because we have this sort of hard-coded array here. And then the allocator is going to be, whoops, we have adds. $20 seconds left. Cool, and we're back. So we want to use the pframe data allocator for this. We need the address of that. And I'm going to move this. I'm going to move this here. I'm going to do away with this. I'm going to do away with this too. I just write 10 here. UI mesh counts. I don't feel like I really need to maintain that anymore. So what we're going to do here is we're going to say if the generation is not invalid ID, meaning it's actually loaded and ready to go, then we're going to say darray push, and that's going to be ext data geometries, and the value that we're going to push there is going to be data, which we don't have yet. We're going to pull that. Did we actually have? I think we did that here in the build, right? So we will put this here. Right. We will delete this, render data. Okay, we'll call this render data. Fine. M geometries. Oh, right, because each mesh can have geometries. Right. So let's see. State UI meshes i.geometry geometry count, right? So let's say U32 geometry count is that, right? For U32 j equals 0, j is less than geometry count plus j, right? And then we will wrap this entire thing within that, right? So this is going to be M, I think, is meshes in this case. Yeah, we use that a couple times. So let's say mesh M equals the address of state UI meshes I, right? And then we can just say M geometry counts, M geometries sub j, M transform. Okay, so we go ahead and add each of those geometries to the array. Once we're done with that, then we can say ext data geometry count equals the array length ext data geometries, right? And that's it for the geometries. So we can actually do away with those two. And then ext data, I think, also just has an array of, whoops. I think it just also has UI texts and it just uses those straight away. So, we're really doing some hacky stuff in here, aren't we? We really need a UI system sometime soon. This is just a test bed, so I guess we don't need it here, but this is not going to be manageable when we have the editor stood up. So let's do ext data UI text count equals 2. right? And then here we'll do ext data text count plus equals 2. Oops, it's UI text count. All right. And then here we're doing an allocation of that. We actually don't need to do... We can actually simplify this a bit. So we're always going to push ext data UI. Oh, just texts. I should probably change that. We're always going to use these. So the first value is going to be the address of state test text, right? So that's that one. And then it's going to be system text, right? So that's those two objects. Debug console text. Debug console get text. Actually, I don't even need this. So this can move like down here. Actually, no, we want that here. So let's remove this, and then we'll move this up here. Oh, that's why this was up here. Okay, so that's needed for that check. Okay, so actually we can just copy this line twice, actually. And we can say, whoops, we can say debug console text for that one. And then that for that one. Right. Let's see. Don't need that guy either. Okay. So, we push everything we need into that array. Then we can say ext data UI text count equals the array length ext data texts. And then we can get rid of all of that, right? All right, so that's the geometries, that's the UI texts. The only other thing we need to check on is what this packet build is doing. What do I do for strings right now? Like, do you mean in terms of like hashing strings? Oh, plain old const character, yeah. Yep. Plain old C strings. We do have UTF-8 capability, you know, just using multiple bytes or interpreting multiple bytes at a time. We do have that. That's how I'm able to get like the kanji and stuff to show up on the screen. But yeah, all of our strings are just plain old C strings. Which, I mean, for like higher level code, I might eventually put in a structure for that, like our own kind of string structure with a little bit more robust methods and stuff. But like we have a We have an entire file full of functions. Converting types, appending, all kinds of stuff, right? And I've already got kind of some of this stuff in here for like a k-string structure that kind of tracks some of this stuff for you, but I'm not using it anywhere yet. So yeah. Okay, so the packet build. So it looks like we're just taking a copy of this stuff. I don't need to do any of that. This is just setting that to the extended data. This is creating geometry render data, which I've already done. So actually, looks like we're done. I think we are done. At least with our data gathering, right? So we have that hooked up. We're not actually calling our... Oh, wait a minute. Oh, yeah, we haven't refactored this yet either. So this is going to be the next thing that has to happen. Which I guess... Right. We just need to make that. And then... These are the packets, which need to go away. And I think, actually, we might just be able to say Rendergraph execute frame, address of state, frame graph, and then p-frame data. And then I think this actually returns a Boolean. Yes, it does. So if that fails, fail to execute render graph frame. So I know that there's some stuff about this where it's absolutely not going to run right now. So I'm not even going to try it. Because we still have all of our view stuff is actually still being called and set up and all that. I don't think we're actually hooking into call or set up our render graph. So we need to actually call the functions that set all that stuff up. And there's some stuff with frame buffer attachments that we're going to have to do as well, that the view system is kind of doing for us. So the view system is taking care of a couple small things that we're going to have to handle. But the good news is I think we are most of the way there. It's going to just be a matter of kind of debugging what we have. So I guess I can try and build this real quick, but I think it's going to fail pretty quickly. So 297. And I'm like over time here, so I actually need to kind of get going. Oh, did I might not have saved everything. Oh, still saying 297. Incompatible. Oh, I'm in the wrong file, you dingus. Oh. That's a double point. Oh. I don't need the address of that. Oh, I did it again. 309. Almost. So close. All right, so... Oh, unused function. Yeah, that actually kind of falls in line with what I was expecting. So I'm actually going to leave that there as a reminder of where I was. and let's see, add. So let's see, Rendergraph, pass data gathering, removal of render packet logic from main loop. All right, and the source will be available to you guys there, so you guys can actually see the code if you want to. Let's see, a structure can improve some stuff, no, like really long strings that you don't have to call string length or something. Yeah, exactly. So for like higher level code, yes, but I don't really use a whole lot of strings on lower level code, especially like anything that's in the main loop. Like I try not to use any sort of string processing there unless I absolutely have to. Unless it's like literally dealing with like text that's written to the screen or something. Otherwise, I try to avoid all type of string processing mid-frame. So if I need to do anything like that, like I would probably just use an integer identifier or hash the string and use that instead. But I try to avoid doing that stuff in the middle of a frame. I try to offload most of that string processing onto like resource loading, so at like load time that stuff can happen, but that's about it. So yes, for higher level code, when we get ready to write game code, we're absolutely going to want that, but for like core level stuff like this, no, not really. All right, so this is where I'm going to leave it for tonight. Let me see who is on that I can raid. Let me see. So let's go with Jitspo, because he is working on a retro FPS using Godot, and so I think that's who we're gonna raid. Let me just get that going here. All right, cool. So, yeah, that's going to do it for tonight. Thank you guys so much for following along. I will drop a link to Kohi in the chat, kohiengine.com if you guys want to check that out, as well as all my socials. Make sure to follow me there to get updates on this project along the way. And, yeah, that's going to do it for the stream tonight. So thank you guys so much for following along, and I will catch you guys later.